Very good morning, friends. I extend a hearty welcome to my YouTube channel. Friends, in today's session, we are going to study the projection of points which lies in the first angle. So, which we call it as first angle projection. So, in the first angle projection, the point is in the first quadrant. So let me tell what is vertical plane, horizontal plane, and the line of intersection of VP, HP, and so on. Friends, this vertical plane is a plane which is fixed, and the horizontal plane, which is at 90 degrees to the vertical plane, can be rotated downwards to bring it in plane with VP. That means HP will come below the XY line and VP is fixed. We will be able to rotate only the horizontal plane downwards in the clockwise direction. Now friends, this is a very important chapter in engineering drawing or engineering graphics. And here friends, there are four important cases when the point is lying in the first quadrant. So let me take one by one and explain how the point is seen in the front and top views and how to represent it in 2D. Friends, the most important, one of the important point of these points is a point lying on lying on HP and 20 mm in front of VP. In front of VP. So this is one of the cases I have taken. Say there is a point. We call this point as A. Point is A. I represent it by A. That is on HP on 20 mm in front of VP. See friends, in engineering drawing or graphics, visualization is very important. So here, since this is the prerequisite to study the projection of lines, planes, etc., we should have clear concept about the point lying in the first quadrant. So there is a point A. So it is lying on HP. HP is horizontal plane. And here say I have a point A which is 20 mm in front of VP. So from here to here, the distance of this is 20. So I will show here, there is a point A, capital A, which is lying on HP and at a distance of 20 mm from the vertical plane. So friends, when you see this point in the direction perpendicular to this, that's called the orthographic projection. The shadow of this point falls on XY. XY, as you can see, is the line of intersection of VP and HP. So here, the point you get here is A dash, and A dash represents the front view of the point. So let us mark in the first angle projection, XY is marked with VP and HP. I will tell you what the reason for marking like this. Friends, in the first angle projection, this VP is a fixed plane. The horizontal plane can be rotated. So VP is fixed and it comes above the XY, and HP can be rotated downward through an angle of 90 degree, and we show it by VP by HP. In the same way, if the point is in third quadrant, then HP will come here and VP, this is how we represent the point or the coordinates of the system in third angle projection. Now let us restrict the study only to the points located in the first quadrant. When you say it's first quadrant, it is on HP, or on VP, or on XY, or anywhere above HP and in front of VP. So there are four important cases. The first case I have taken, the point A is 20 mm in front of VP and on HP. Friends, whatever be the distance of the point on HP, anywhere, the front view of that point is always obtained on XY. So I mark the front view as A dash anywhere on the XY line. And how to get the top? This is the front view, FV. To get the top view of that, one should see from the top. When he sees from the top, the shadow of that point A coincides with that point location of A. Then we are going to rotate it in the clockwise direction. So when you rotate this plane in the clockwise direction through 90 degree, the location point A which was here, the top view, it moves to this location. And this point is called A. So I write a vertical line from there through a projector of length 20 mm, and I mark this point as small a, that is the top view. So friends, whenever any point lies on HP, its front view will always fall on XY, and the top view is seen below the XY line as shown. So this is one of first part of the question. Similarly, friends, let us take up a problem on a line, on a point, sorry, which is on VP. So friends, we have got a point. So let us write down the question. Part B, a point B is on VP and 25 mm above HP. Above HP, from HP, they mean the same. In front of VP, from VP also mean the same. Friends, you have got this point B on VP, on this vertical plane. Suppose I call this as point B. This is at a vertical height of 25 millimeter from HP. Above HP or from HP. So what happens, friend, when you view this point perpendicular to VP, you get the shadow of the front view coinciding with the point. Hence, I am going to mark the XY line as usual. Mark VP by HP indicating first angle projection, and mark the front view, the point B, at a distance of 25 mm above XY. So I will mark here B dash, which is called the front view of the point B at a distance of 25 mm above the XY or above HP or from HP. Friends, after obtaining the front view, we have to obtain the top view. Friends, when you look at this point from the top, whatever may be the location of the point anywhere on VP, the shadow of this falls on the XY. And hence, friends, after getting that shadow, we are going to mark that on XY, and this point is going to be B. B is the top view of the point which falls on line with this point B dash. The line connecting B dash and B is called a projector. So two cases we have studied, and let's move on to the third case. The third case is case number 3 or C. Point C lying on XY. So what's the meaning of this? There is a point C which is lying on XY. So the point is lying on XY means it is on the line of intersection of VP and HP. So friends, we have this point C here, capital C. And friend, when you look in this direction, the shadow or the front view C dash falls on this. And when you look from the top, the shadow of this coincides with there. So C dash is the front view and C is the top view. So for any point lying on XY, the front and top views coincide and they will be at the same point on xy. So mark the xy line, mark VP and HP, mark this point. Above this you mark it as C dash, that is the front view, and C below that is the top view. So this is how we obtain the projection of a point which is on the line of intersection of VP and HP. Friends, in the same way, let us move on to a problem on a point. That is a point which is above HP in front of VP. So any point in this quadrant, this is the first quadrant, it will above HP in front of VP. So case 4 or case D, the last case, is point D is 25 mm above HP and 30 millimeter in front of VP. So this point is somewhere here. That is, it is at a height of how much? 25 mm above HP. So very obviously, after marking this XY, VP and HP, you can show this front view which is 25 mm above. So I just mark a point here, call it as D dash at a height of 25 mm above this. So D dash represents the front view of the point capital D. How to obtain the top view? The point is 30 mm in front. So the shadow of that falls 30 millimeter in front of this VP. The horizontal plane is to be rotated so as to bring it in plane with VP, and we are going to get the top view here, and the distance will be whatever the distance it is in front of VP, that is 30 mm. So on this line through this D dash, you mark a point D, the top view of that at a distance of 30 millimeter from VP or in front of VP. So friends, these are the 4 important points or the locations for any point lying in the first quadrant. Friends, remember, this projection of points is a prerequisite to study the problems on projection of lines, planes, solids, etc. Thank you friends for watching my YouTube video. Have a wonderful day.